Let us evaluate the integral of tangent to the power 6 of x. When dealing with an integral of tangent, you would need to first factor out a tangent squared. So this would be the integral of tan to the power of 4 of x multiplied by the factored out tan squared of x of dx. The next step would be to transform this factored out into its trigonometric identity. Tan squared of x would be equal to secant squared of x minus 1. And now, let's substitute it. Next step would be to distribute tan to the power 4 of x among the parentheses. And we can split this integral into two parts. For this, let us focus on this first part, wherein in this case, let u here be tangent of x, and taking the derivative of this, it would be equal to secant squared of x dx. And now, take the dx in here. So transposing secant squared of x to the other side, this would be equal to du over secant squared of x. By substituting it, this would be the integral of u to the power of 4 multiplied by secant squared of x. Know that u to the power of 4 corresponds to tan to the power of 4 of x. And multiply it by dx, which is equal to du over secant squared of x. You can see secant squared of x would cancel, which leaves you with a value of u to the power of 4 of du. And taking the integral of u to the power of 4 of du, which is equal to u to the power of 5 over 5. And by putting u back into its original form, this should be equal to tan to the power of 5 of x over 5. Now, this is the integral that corresponds to this one. This is the integral that corresponds to this one. Now that we have finished our first part, let us move on to the second part. You can see here that the integral of tangent to the power 4 of x, again, we are dealing with an integral of tangent. So what we need to do here again would be to factor out 1 tangent squared of x and to transform it again. And now we can transform this, which makes this equal to secant squared of x minus 1 multiplied by dx, and to distribute tangent squared of x among this again. Now that we have distributed this, we can now again split this integral into two parts, which makes this the integral of tan squared of x secant squared of x. And for this, since they both have negative, this would be plus, you should have put the x here first, plus the integral of tan squared of x of dx. Now focus on this part. Let u here again be tangent of x. It's just a repeat of the step in the previous part. And taking the du here, it would be equal to secant squared x dx. And isolating the x, we would have a value of du over secant squared of x. By substituting this would be u squared multiplied by secant squared of x multiplied by dx, which is equal to du over secant squared of x. You can actually see here that secant squared of x would cancel, which leaves you with a value of u squared multiplied by du. And just copy this first. Now that we have done this one, let us focus on this next part now. Since we already have here a tangent squared of x, we can now just simply transform it. So this would be the integral of secant squared of x minus 1 of dx. And now we can actually take the integral of it one by one, starting with this first. The integral of u squared of du would be u to the power of 3 over 3 plus the integral of a secant squared of x is actually equal to tangent of x. This was based from the derivative of tangent of x, which is equal to secant squared of x. The opposite of a derivative is an integral, so we can say that the integral of secant squared of x is equal to tangent of x. And for the last part, the integral of 1 dx is equal to x. And add plus c now. And now this is the integral that corresponds to these two. Now let's just mix all of our answers, starting with this first one. It will be tan to the power 5 of x over 5 minus u cubed over 3 plus tan x minus x plus c. And now for our final answer, let's just put u back into its original form. So this would be tan to the power of 5 of x over 5 minus tan to the power of 3 of x over 3 plus tan of x minus x plus c.